Hi, in this video I'm gonna show you my DIY Reflow oven, quickly how it's made, how it works, and then a little bit longer part showing how it was built. The frame of this is just a normal cheap toaster oven from Amazon, and I have just replaced a lot of things inside, added thermal insulation, controller, then the relays inside and everything. So there was quite a lot of work. So if I open it, you can see that pretty much everything inside has changed. Here's the tray where you put the PCBs in. There are two heating elements on bottom, two on top, and then there's extra boost element here on bottom as well. There's a thermocouple for measuring the temperature, and everything is covered with this thermal tape or these thicker kind of aluminium thermal insulation panels. The red stuff here inside is kind of thermal silicone glue, which is used to seal all the holes and gaps. And then this thing here is there's a Controleo controller inside, Arduino based controller, and here's a servo with this aluminum piece. It can open the door when the reflow is done to cool it down faster. Controleo is a capable reflow oven controller, but one of the reasons I picked it is that they have excellent instructions on their website how to build a DIY reflow oven, and also that they are offering this kit where basically everything comes with the controller. There is a substantial amount of work when building this type of oven, especially if you need to do some changes in the metal chassis. I did this as my Christmas holiday project. One important thing to mention is that safety first. We're dealing with the mains voltage here, so you need to know what you're doing or leave the work to someone else. And the most important thing is to use good solid safety ground connection. This is the Controleo kit I received from Visu. So it cost quite a bit more than the controller itself alone, but as I will show you, it is worth to get the whole kit. Here's the controller itself. There's a ceramic blanket you put around the oven casing. There's the supply for the controller. This is the thermal glue, kind of the silicone thing, the servo, a bunch of cables. There's the boost element, cable tires. Here are the solid state relays and also screws and stuff for that. It is the panel where you put the relays on, some extra aluminium pieces you need for installing the controller case and the door opening system. Here the thermal, the insulation stuff. So this DE stuff is actually very expensive. So if you start looking at even that, how much it costs, even to get the small panels, if you can find somewhere, this stuff already is quite expensive. Here's the PCB tray. This was a little bit too big for my oven, so I needed to cut a little bit here. Here's just the Controleo controller with touchscreen display. There was also 1 GB SD card for the controller where you store the profiles. Yeah, so this is Arduino based. There was this plaster included and I was laughing at it a little bit, but it took approximately 1 minute after opening the case when I had a cut on my finger already. So as say warned in the instructions, all the edges are very sharp in the ovens. So these are the ovens I got. This is Netta oven from Amazon UK. So that's how they look like. In the description it actually says it's 650 watts, but actually here seeing the instructions and when I opened also what it says on the boost element, the heating elements, so it is actually 800 watts. And this is how it looks inside. So there's one element at the bottom, one top, covered with these kind of protecting metal pieces, And the problem with this is that these are in series. So here behind this panel are the controlling, very simple controlling things, and then here just goes wire between the two. So you cannot really use them like that because you need to be able to control top and bottom heater separately. This is the oven opened. Worth noting that all these cables here are like can withstand higher temperature, so it's good to save these when tearing the oven apart. You can use them to wire your extra things there. And here's the door opening mechanism, which I also needed to change a little bit later on. So this is just taking everything apart because I needed to do some metal work to make holes for the extra heating elements. So these are the elements, 400 watt each, 115 volts connected in series. What you have inside is just kind of resistive element. So now I'm in a shed where I've been doing some of the metal work, which is the most annoying part of this oven build. So basically the old places for the heater elements were here, and because I'm using 4 now instead of 2, so I'm putting on the sides, 2 in the bottom and 2 on the top. So how I've been actually doing these holes, I just basically drill holes and then I use chisel and hammer just to open the holes bigger, and it's quite thin still, so it works okay. It's not going to be pretty, but it doesn't matter. It's going to be filled with high temperature gasketing anyway, and yeah, as long as it works and it's well insulated, that's good enough. So this is the oven after the metal work I did. So now instead of these 2 holes in the middle for 1 element, there's 2 at the bottom and 2 top for 4 elements in total. So there's solid state relays and the assembly things, everything. This was included with the kit. Also the aluminium panel to install them on. So these make it a little bit warm. So this aluminium is mechanical support, but also acts as a small heatsink. And this insulation was also included in the kit. So here they are installed in this bit. So then this is just gonna be screwed inside the oven where the original controlling bits were in. This red stuff here, that's the thermal silicone glue thing, which is very strong smelling and sticky and gets everywhere, so be careful when using something like this. So basically all the gaps are filled with this one, and this is now after all the insulation things installed. So the glass door is covered with this heat reflecting tape, just leaving a small window there where you can see inside a little bit. Bottom, back and top are covered with this panel, which is kind of like it's aluminium, then some kind of felt that it's a few millimeters thick. Of course everything is designed to withstand quite high temperatures. So the idea is not to cover everything, every single small bit, and there wasn't enough of the material to do that, but it's just to cover the largest surfaces with some kind of reflective material. So now the 4 elements are in, but as I didn't really have anything here to keep them in place as it was in the original hole, so I used these metal bits that was inside to keep the elements in place. So they will mostly be in place by the silicone glue thingy, but this is just some kind of backup that they wouldn't become loose. Yeah, you have a mains fault that's going in, so you don't want it to be touching anything. But anyway, remember, you must use proper safety ground in these kind of things, because if something goes wrong. That is from the inside, showing how the elements are installed. The thing is that the heating elements are still quite close to the thermal panels, and what it's been saying in the instructions that if you really run it full power for a long time, which shouldn't happen when you use the controller, but these things may actually still burn, so be careful. Don't try just using full on. And also, when it's very hot, it is designed to be used in hot temperatures, so the adhesive glue thing here, it should stay there. But on the top one, it was recommended in the building instructions to actually use screws just to make sure it stays there, it doesn't fall on the element. So I have also, it's not visible here, I think I hadn't done it yet, but I have 4 small screws on the top one to keep it in place. This is after I have applied the silicone glue thingy. So yeah, that's what's basically keeping them in place, but then the metal bit just comes here to make sure that if something happens to the glue. And this is the case for the controller and the bracket for the servo, and this bit will open the door. So all this was included in the kit. This is after the wiring has been done on the solid state relays. So this is a power supply for the controller. It's connected to mains, 5 volts out. This, as I've written here, is a top, bottom, boost relays for the heating elements. Here on the top part it's the mains wiring, and on the bottom side you have the control signals coming from the controller, which is all the wires are coming here, and all these grommet bits and these are also included in the kit. So there's the 4 control signals, power supply, and then the thermocouple coming from inside the oven. Here's the case put in place, and that's after I have modified the door opening mechanism, because it was going here across and obviously it cannot do it anymore. So I needed to put the spring on the bottom side, and this aluminum bit here basically just blocks that this mechanism cannot touch anywhere here where the mains voltage is. Well, this is the door closed, so this was door open and this is door closed, so it just slides here. There's not much space, but it works okay. This was for the door opening mechanism, so this aluminum bit was also included in the kit. It depends on the oven, what type of oven you are using, where you can put it. So I just installed it here. There was a wee gap between things, so it just went there, and I bent the edge a little bit to make it more solid. And then the servo mechanism just comes here, and yeah, that's why it can open it a few centimeters, which is enough to cool it down very quickly. Yeah, that's the PCB tray inside. So there are wee bits of the insulation here, was also included in the kit. So the idea is just to leave a little bit of few millimeters of space here at the back and also at the front, so the air can go around a little bit. Also, what I didn't use these metal bits in the beginning because I thought they were just to protect the heating elements from mechanical stress, that you don't knock them or anything. But apparently the second function of these is to prevent direct infrared radiation. Infrared is really not that good on PCBs because it means that it hits the black and dark components more than bright ones. So I reinstalled these 2 bits on the top elements. Most of the heating is coming from the bottom. It's in the profiles usually drives the bottom elements with higher power, and you also have the boost element there. And then when you have this the tray there in between, it kind of the temperature coming from the bottom should be very even. And that's after I run the first learning cycle of the oven. So the controller contains a learning cycle. It stores the parameters for the PID controller and also gives you feedback how well you've built your oven in terms of power, inertia, insulation. Now this is the first score I got, was excellent, basically full scores on everything, but it does depend on where you put the thermocouple inside. So when I placed it closer to the PCB or inside the hole in the PCB, I got a little bit lower score. It was still 95% or something. What is the right one then to use? I don't know. Eventually I took something in between. I did 3 learning runs, and I took the one where the thermocouple was not inside a hole in the PCB, but just basically touching the PCB to be very close there. Thanks for watching. I hope this helped if you're planning to build your own reflow oven. In the next video we're gonna try some soldering with this oven.